Here's the guts of a Digitech Model 710 portable computing terminal of some kind. This is the power supply for it. It's a somewhat old design switching supply. No integrated circuit, no integrated circuits really of any kind in it except for a couple of potential regulators. Well, otherwise pretty much so all the control circuitry in it's pretty much discrete. And it looks to employ a feedback transformer instead of things like opticouplers, which are commonly found in more modern supplies. Although the transformer has the advantage of it doesn't need a separate isolated supply for the transistor that it is for the transistors that it's controlling, which is something that would be needed with optos. So unless you have photovoltaic opto isolators, but due to their design they're typically fairly slow and too slow to be used in SMPSs. And overall, fairly typical. Aside from that, it's fairly typical and fairly decently designed power supply. It's decent input filtering. Because again, the design for this thing is 30 years old, so it's some degree of quality is to be expected. The actual power supply is only about 26 years old, week 15 of 1987. And the electrical connections on it are go to a couple of these pin headers. This is the mains input, either 115 volt or 230 volt switch selectable, which pretty much just says whether or not the front end is configured as the rectification is configured as a potential doubler or just a Grace bridge. And the outputs, which go to this pin header, and judging from the wiring colors, it's 5 volts, 12 volts, ground, and two other things, one of which is probably another rail because that connects to a potential regulator down there, although due to the clamping I can't see what the part number is. And the other one is probably either an additional rail or some kind of switching control or something. And there's this board, which connects, which has this 37-pin D-sub connector on it. So this is probably interfacing with some kind of peripheral that this thing's designed to, or system that this is designed to interface with. It's got some for AS240. I think those are bus drivers or data latches of some sort. Don't remember what the part number is offhand. And there's some for LS395s. Don't know exactly what those are, but they're probably more interfacing stuff. As are these DS8837s. Again, don't know exactly what this is. I'll put all these parts in the or what these things are in the description. And there's some AMD Z8358Z. These are Advanced Micro Devices Z8530 PCs. These, I'm guessing, are some kind of interfacing UART type chips. And that P82C54, I'm guessing that's probably memory of some sort that has I know comms protocols or firmware for this board on it. A couple of 2653 AC4C, don't know what those are exactly. Although a lot of this is just going to be communication stuff because it's got this 3.68640 megacycle crystal, and oddball clock frequencies like that are typically indicate some kind of communication stuff because that clock rate is an integer multiple of a lot of common serial data rates. So if you've ever seen something like that, or 1.842 megacycle, 18.432 megacycle, or whatever, commonly whatever that does has something to do with serial or some kind of serial protocol. Some 74HCTLS74A, and those are D flip-flops, 74HCTLS32. It's either an AND or an OR gate, don't remember which. And another D flip-flop and a 74HCTLS157, don't remember what that is. Somewhat unusual logic family. And a PAL programmable logic device with a device-specific code on it. And these somewhat old school DIP2 package capacitors, which commonly used for very high density through-hole boards, just to save on space. And you can still get these, but they're fairly expensive compared to conventional or the similar type capacitors in more conventional packages. They're usually about 50 cents each or so on DigiKey, or at least that's the starting price. And there's this circuit board, which is all the support circuitry for the display. It's a 6-inch or so green screen kinescope, so fairly typical, kinescope, fairly typical type of display for something of the particular vintage of this piece of equipment, which from all the date codes I can find, this thing is from about the late 1980s. Because there's a week 6 of 1988, and power supply was dated 1987. Lots of the chips in here have 1980s date codes, so well, that's about, I think, when this thing was made. That looks to be fairly typical supply board. There's a flyback transformer for the high potential supply for the tube anode. A tunable inductor there for parameter adjustment. That inductor down there, which has a magnet glued on the end, that's fairly common to something that's fairly commonly seen in this kind of display circuitry, because that magnet affects the magnetic properties of the core. That's, again, typical. Number of connections on this, which probably some of these are for various parameter adjustments that are supposed to be user accessible without having to open the thing up, because some things like display brightness and horizontal hold are on this board, but the contrast adjustment is on the back panel, along with a composite input. So one thing I want to see if this board, because I know that this board is one of the parts of this thing, or the display is one of the parts of this thing that does work. What I want to do is see if this has a composite video input or some kind of input so it could be easily interfaced with the composite video stuff. Because if so, then it would make, then what I'm going to do is I'm going to take the display stuff out of this and make a video monitor out of it. So we pulled off sticky pad things, which is fairly typical on these things, or with these sticky pad cable retention things, because the continuous loading of the cable on them causes the adhesive to fail over time. See, this one is still sticking, but that one doesn't have any load on it. That's fairly typical. And down here is the motherboard, or part of the main board for this thing. There's a Intel C8208. That's probably going to be the main processor in the thing. So the number of these MB81256-15, and those are almost certainly memory, because that part number, the -15, or the 256 indicates that these are either 256 KB-bit or KB-byte, probably RAM of some sort, and the -15 is the access time. That's probably going to be 150 nanoseconds. There's some more HCTLS logic stuff. Part numbers, I think, just things like shift registers and bus buffers and whatnot. There's a couple of 100mm pin headers here which interface with the board that I showed earlier. And these silver painted chips are Texas Instruments SN75150s and SN75154s. Those are serial line drivers. So that's just going to be for the printer and remote control ports on the back of this thing, because there's a couple of D subs for those. Then over here are more processor support chips. Don't know exactly what any of these are, but I'll again look it up and what these are and put that in the description. There's crystal bodge with a 470,000 ohm resistor and a couple of, I think, silver mica caps. Those are going to be that's just clock stuff, and given that they're next to this SCN 2681, I'm guessing that that's probably some kind of a clock generator or timing control chip. And there's P82C59A-2, more HCTLS, a couple more programmable logic devices down there. Another P82C54 and some P82C55A and P8279-5. And here's the underside of the motherboard with a number of bodge wires on it. Although they all look to be fairly cleanly done, just fairly typical. I think it's 28 gauge or 38 gauge. 28 gauge or 30 gauge, I mean, Kynar insulated wire wrap wire, so fairly typical. A couple of these footprints, which I'm guessing for PLCC or some kind of similar package, ZIF sockets, because I saw one of them down there, and judging by the two footprints, there's going to be two. Again, Digitech, copyright 1985, blah 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 blah. Vision, blah blah blah, etc etc, you know the drill. Here's another interesting part of it. This is the cooling fan for it. And one thing of interest is that this is a brushed motor. So this looks like it might predate or might have been hideously expensive at the time. The more typical electronically commutated brushless fans that are typically seen today. Just something interesting. And here's the whole motherboard, or main board. A couple of ZIF socketed devices here, which are. Is that how you open? What is it There's a ZIF socketed device there. Another one there. This one is a Intel RS-82730. That might be one of the processors in this thing. Some more memory chips. MB84168-15s. More programmable logic devices. Another EEPROM. And aside from that, a lot of this is just various glue logic. Most of these are HCTLS, some fast devices like that 74161, and just some regular low power Schottky devices like 74LS123 and a 74LS138. That one is a dual monostable oscillator. That 74LS138, I don't remember what that is exactly, but or is it just TTL? And then there's a composite video input, probably some analog guff for that. 74. But that's the Texas Instruments SN75428. So I think some kind of line driver. HCTLS00 quad NAND gate transistors. It's for HCTLS 244. Some kind of shift register or something. A couple of power resistors in the corner here. So probably some of this stuff might be video or whatever encoding for the display, was hooked up with this edge connector. And the thing is that there was this 7812 in a TL3 package mounted on the aluminum frame of it. This is the heat of the devices of the machine, just as a heat sink for this. So probably the switching supply that this thing came with might not have the best of regulation, but whatever. This fifth socket was a Intel R80186, so processor. This one has a TIX tool, ZIF socket, and this one's Amphenol, so all fairly good stuff, although given the age of this thing and what it cost originally, that's probably to be expected. I think it's a 32 megacycle oscillator and Siemens SAB 82731. Saying that might be another clock generator or something.